Picture standing on the floor of the Mediterranean Sea, not swimming through it, walking on it, dry ground under your boots, 3 miles below where the ocean surface used to sit. The air here is so dense it feels like a weight on your chest, closer to being 20 feet underwater than standing outside, and the heat. Summer temperatures on the seafloor once climbed past 170 degrees Fahrenheit, hotter than the inside of a medium-rare steak. This is not some alien world. This is the Mediterranean Sea roughly 6 million years ago after it died. Rewind a little further and the sea is still there, blue and full and connected to the Atlantic Ocean by 2 narrow gaps in southern Spain and northern Morocco. Those gaps are called the Baetic and Riphean corridors, and they are the only reason the Mediterranean exists at all. The sea evaporates about half a meter of water every single year, far more than rivers pour back in. Without a steady supply from the Atlantic, it is always losing. Around 7.1 million years ago, the slow collision of Africa and Europe pinched the Baetic corridor shut. All that remained was the Riphean corridor in Morocco, one last narrow tap keeping an entire sea alive. By 6.8 million years ago, that tap started closing too. Here is where it gets strange. The Mediterranean did not vanish all at once, it choked in stages. First came thick layers of gypsum settling across the shallow edges of the basin, the sea thickening into a toxic, oxygen-starved brine. Then, around 5.6 million years ago, the last connection sealed completely and the real drawdown began. Water levels fell by 1,500 to over 3,000 meters, exposing almost the entire seafloor to open sky. In the deepest trenches, what was left behind was rock salt, precipitating out of shrinking brine pools like a supersized Dead Sea. Picture a bathtub with the drain plugged but the faucet barely dripping, sitting in a room that never stops heating up. Eventually, the water loses, and all that is left is a crust on the porcelain. The Mediterranean's crust turned out to be over 1 million cubic kilometers of salt, enough to bury the entire continental United States 300 feet deep. And that heat at the bottom was not some coincidence. Air sinking 3 kilometers into an empty basin behaves exactly like a bicycle pump. Compress a gas and it heats up, with no outside flame required. That is how a seafloor ended up hotter than a steakhouse. While the sea was dying, something else was racing against it. Rivers across Europe and Africa suddenly had nowhere to empty out. To reach the retreating brine, the ancestral Nile tore backward and downward into the land, carving a canyon that plunged over 2,000 meters deep, cutting straight past where Cairo stands today. It is, in places, deeper than the Grand Canyon, and it is still down there, buried under the modern Nile Delta. When the sea eventually returned, it drowned that whole gorge and sealed it under 5 million years of mud. The exposed seafloor also became a bridge, letting animals wander across the newly dry basin. Then the water came back and trapped them. Stranded on shrinking islands with limited food, elephants on Sicily and Malta evolved downward, generation by generation, until Paleoloxodon falconeri stood barely a meter tall, roughly the size of a large dog. For 100 years, this entire story was just an idea, argued over without real proof. Then, in 1970, a ship called the Glomar Challenger drilled into the Mediterranean seafloor. Geologists Kenneth Aitchis and William Ryan, working with micropaleontologist Maria Biancasita, were chasing a strange unbroken signal in their sonar data a layer scientists called the M reflector. When the drill finally broke through, it jammed on something hard 200 meters down. What came up was a knotted, honeycombed mineral called chicken wire anhydrite, a structure that only forms one way, baking in shallow mudflats under direct, open sunlight. They were holding sun-baked desert rock pulled from 3 kilometers beneath the open ocean. That was the proof the Mediterranean seafloor had once been a sunlit desert, not a seabed at all. The ending, when it came, was just as violent as the beginning around 5.33 million years ago. The barrier at Gibraltar finally gave way. Water didn't trickle back in, it thundered through a carved channel at 100 million cubic meters per second, a flow rate 1,000 times greater than the Amazon River. Sea level rose more than 10 meters a day. Within months, perhaps 2 years at most, a basin 3 kilometers deep was completely full again. Somewhere under the farmland outside Cairo, that buried desert canyon is still sitting there, sealed in mud, forgotten by everything living on top of it. And the entire Mediterranean Sea, the one people vacation on today, only exists because water eventually found its way back through one narrow gap in the rock. So maybe the real question worth sitting with is this: how many of the seas, coastlines, and systems we treat as permanent are actually just one closed gateway away from disappearing?